Good day everyone. I'm Joshua Miguel Orelota from BSECE3A. Today I will discuss about the performance task number 11, the subject ECE23. So the topic I will discuss is about non-orthogonal multiple access or NOMA. So objectives, definition, comparison of NOMA, which is non-orthogonal multiple access, versus OMA, which is orthogonal multiple access. Concept of NOMA, cooperative NOMA. So definition, NOMA, which is non-orthogonal multiple access, is one of the most promising radio access techniques in next generation wireless communications. NOMA offers a set of desirable potential benefits such as enhanced spectrum efficiency, reduced latency with high reliability, and massive connectivity. The baseline idea of NOMA is to serve multiple users using the same resource in terms of time, frequency, and space. So recent studies demonstrate that NOMA has potential to be applied in various fifth generation 5G communication scenarios, including machine-to-machine, M2M communications, and the Internet of Things IoT. Moreover, there are some existing evidence of performance improvement when NOMA is integrated with various effective wireless communications techniques such as cooperative communications, multiple input, multiple output, MIMO, beamforming space-time coding, networking coding, full duplex, etc. Given all advancements and experimental outcomes, standardization of NOMA has been established for the next generation American Digital TV Standard ATSC 3.0 under the term Layered Division Multiplexing LDM, and has been initiated for the third generation partnership project 3GPP under the name Multi-User Superposition Transmission Must. Another definition, since the principle of NOMA allows multiple users to be superimposed on the same resource, this leads to interference for such systems. Consequently, existing resource management and interference mitigation techniques, especially for ultra-dense networks, need to be revisited due to the incorporation of additional interference this new technology brings for the similar reason, beamforming and the resultant other problems in massive MIMO systems. Introduce additional challenges and need to be solved in order to achieve full utilization of these technologies. From the perspective of physical layer, existing channel coding, modulation, and estimation related problems need to be revised as well. So, cognitive, cooperative, and visible light communications all are conducive paradigms under NOMA systems. Compared to conventional systems, however, the resultant evolved problems due to the incorporation of this new technology need to be solved before acquiring benefits from these paradigms. Although NOMA techniques offers numerous advantages, the enhanced information sensing ability of more users via this technique leads to higher security and privacy threat. Therefore, a series of security problems from the physical to application layers need to be solved in order to build a robust, efficient, and effective system via this technique. NOMA versus OMA comparison. So OMA means orthogonal multiple access. Advantages: simpler receiver detection. OMA has disadvantages: lower spectral efficiency, limited number of users, unfairness for users. So NOMA also has the advantages: higher spectral efficiency than OMA, higher connection density than OMA, enhanced user fairness than OMA, lower latency, supporting diverse QoS. So NOMA also has disadvantages, in which is increased complexity of receivers. So this is the concept of NOMA. So this is the base signal represented by a triangle. The two users UN and UF represented by a rectangle, which is the near user and the far user. This is called the near user because it is near the base signal, and this is the far user because it is farthest this is the farthest self signal. So that do has also H and HF. So that's the base signal has a signal for the near user and a signal for the far user. After the transmission, the UN will use the self-interference cancellation to decode the signal. So this is the signal for the near user, which is the red one. So after that, the far user will also decode its signal, but it can, due to far distance to the base signal. So it will decode the signal from the near user. So this is the result of the signal from the near user. So concept of NOMA. Channel capacity comparison of NOMA and OMA. So this is the rate of the far user, the rate of the near user. So the red line, straight line is the one that, so the red line is the OMA and the yellow line is the NOMA. If the rate of the far user is equal to the rate of the near user, so it is OMA. So if the rate of the far user is not equal to rate of the near user, so it is NOMA. Cooperative NOMA. The same message transmitted and reduce outage probability. Relaying can virtually extend the coverage area of the base station. So cooperative NOMA is the broken lines, which is the signal from UN to UF, and the non-cooperative NOMA is the signal from the base station to the near user and the base station to the far user. So summary: NOMA means non-orthogonal multiple access. The baseline idea of NOMA is to serve multiple users using the same resource in terms of time, frequency, and space. So NOMA is better than OMA. OMA means orthogonal multiple access. So that's all. Thank you.